Have you heard the rumor that NASA is using up all our oxygen? It sounds like something out of a science fiction movie. Imagine a world without breathable air, all because of rockets blasting off into space. Is there any truth to this? Well, it's a bit more complicated than that. The truth is, NASA isn't exactly our oxygen. But they are using a lot of it, and it does end up leaving our atmosphere. Don't panic just yet. Let's dive into the science behind this cosmic oxygen mystery. Oxygen is pretty important. It's the lifeblood of our planet, essential for the survival of almost all living organisms. Without it, life as we know it wouldn't exist. We need it to breathe, of course. Every breath we take fills our lungs with this vital gas, allowing our bodies to function properly. But did you know that oxygen is actually a very reactive element? It doesn't just sit around, it loves to interact with other elements. It loves to combine with other elements, and these combinations are called oxides. This reactivity is what makes oxygen so fascinating and versatile. Rust, for example, is iron oxide. It's a common sight, especially on old metal objects left exposed to the elements. It forms when iron reacts with oxygen in the air. This process, known as oxidation, is a perfect example of oxygen's reactive nature. Oxygen is also a key ingredient in combustion, which is just a fancy word for burning. This process is crucial for many of our daily activities. When things burn, they are rapidly combining with oxygen and releasing energy in the form of heat and light. This energy is what powers everything from campfires to rocket engines. This is important for our story about rockets and where Earth's oxygen is going. The same oxygen that fuels our bodies and rusts our metals also propels our spacecraft into the cosmos. Here's the thing about rockets. They need a lot of power to escape Earth's gravity. That power comes from burning fuel. And just like a campfire needs oxygen to burn, so do rockets. Rockets carry their own oxygen supply because there isn't enough in the upper atmosphere to support combustion. So when a rocket launches, it's combining its fuel with oxygen, creating a powerful explosion that propels it upward. The byproduct of this combustion? Water vapor, H2O, and carbon dioxide, CO2, mostly. These gases are released into the atmosphere. Section 4. Beyond Earth's atmosphere. Where does it go? Now, some of that water vapor and carbon dioxide might stick around in our atmosphere. These gases play a crucial role in maintaining the Earth's temperature and climate. They trap heat from the sun, creating a greenhouse effect that keeps our planet warm enough to support life. But some of it escapes into space, especially the lighter elements like hydrogen. This process is known as atmospheric escape, and it happens because the Earth's gravity isn't strong enough to hold on to these light gases. Over billions of years, Earth has lost a tiny fraction of its atmosphere to space, including some oxygen. This loss is minuscule compared to the vast amount of gases in our atmosphere, but it's a continuous process that shapes our planet's evolution. But here's the thing. Earth is constantly producing oxygen through photosynthesis. This process is carried out by plants, algae, and some bacteria, which use sunlight to convert carbon dioxide and water into sugar and oxygen. Plants and algae use sunlight to convert carbon dioxide and water into sugar and oxygen. This not only provides the oxygen we breathe but also forms the base of the food chain, supporting all life on Earth. It's like a giant natural oxygen factory. Every leaf, every blade of grass, every tiny algae cell is working tirelessly to keep our atmosphere balanced. So, while some oxygen is lost to space, it's being replenished all the time. This delicate balance is what makes life on Earth possible, a continuous cycle of loss and renewal that has been going on for millions of years. Section 5. Why should we care about oxygen in space? Understanding how oxygen behaves in space is important for a lot of reasons. Oxygen is not just a vital component for life as we know it, but it also plays a crucial role in various scientific and technological advancements. For one, it helps us understand how Earth's atmosphere evolved and how it stays in balance. The delicate balance of oxygen and other gases in our atmosphere is what makes life on Earth possible. By studying oxygen in space, we can gain insights into the processes that maintain this balance. It also helps us develop more efficient rocket fuels and life support systems for future space missions. Oxygen is a key component in rocket propulsion, and understanding its properties in space can lead to more efficient and safer space travel. Life support systems that provide breathable air for astronauts rely heavily on our knowledge of oxygen. Maybe one day, we'll even use this knowledge to terraform other planets, creating breathable atmospheres on worlds that are currently hostile to life. Imagine a future where humans can live on Mars or other planets, thanks to our understanding of how to manipulate oxygen levels. So the next time you take a deep breath, remember that oxygen is a precious resource, both here on Earth and out in the vastness of space. It's not just about survival, it's about exploration, innovation, and the future of humanity. Keep asking questions about the universe. The more we learn, the more we realize how interconnected everything is, from the air we breathe to the stars we gaze upon.